Good evening, everyone. Welcome you all to day 3 of AlgoQueen training session. Today we have with us Ms. Shiva. She is currently an intern at Cisco, and today she will be doing the topic searching and sorting. Over to you, Shiva.
Thank you. So hello, everyone. Good evening. So in this session, we'll be discussing about searching and sorting. So please feel free to post your queries in the chat box or Q&A panel. So coming to today's agenda, we'll be looking into searching and few searching techniques, namely linear search, binary search, ternary search, and also we'll be looking into what sorting is and a few techniques like bubble sort and merge sort. So coming to searching, answering the three basic questions like what is searching, why, and how. So searching is nothing but finding an element or an item with a specified properties from a collection of items or any other things. So let's make the session a bit interactive. So why do you think we need searching? So you can post your answers like why you feel searching or search algorithms are important in the chat box. So you can type any reason, like whatever you feel like why, yeah, okay. Okay, that's great. Okay, so to find the required data, help finding data most efficiently. Okay, very good. So basically, like in today's modern era, the computer stores lots of information and we need some kind of technique to read these information proficiently. So it's like the same thing that you're saying. So that's the main reason why we go for search algorithms and techniques. Okay, so moving on to the search techniques. So the first one which we are going to see is a linear search. So you can also call this as sequential search. So this is the basic logic or the process that is involved in linear search. So let's say that you have an array containing like a few elements, for example, the 10, 50, 30, and so on till 40. And one more important thing is like the array need not be in a sorted order. It can be in any random order. So say your target value is 20 and you have to find where 20 is. So you have to return the index. So what we basically do is like we first go to index 0 and we compare the value in at index 0 and the target value that you have to find. So 20 and 10 are not equal. So what you do is you move on to the next index, which is index 1. So there you find the value 50, which is again not equal to 20. So you move on to the next index, which is 2. So there you find the value 30, which is again not equal to 20. So you keep on repeating the same step and until you find the value, the index where your target value is present. So this is called linear search technique. So as the name suggests, it goes linearly and sequentially. So it's basically like you iterate throughout the array and find like if your value is present or not. So coming to the time complexity of linear search, you have like two things, like one is the best case and the other is the worst case. So in best case, I'll say that you have to find 10. So 10 is actually present in the 0th index. So you will get the index where the target value is present in the first comparison itself. So in that case, your time complexity is going to be order of 1. So this is your best time complexity. But coming to the worst case, say you have to find the element 40. So 40 is present in the 8th index, so which is like to generalize, it is the nth index. So basically, you have to iterate throughout the whole array. So your worst case time complexity would be order of n. Okay, so let's try to implement the linear search. So before we implement linear search, so I'm going to use Python programming language. So let me tell you two things. One is traversal by elements and traversal by index. So say you have some array which contains 1, 3, 5, some random numbers. And the first one is I'm going to show how traversal by elements works. So for I in ARR, I'm going to just print the elements. So let's try running this. Okay. So here you can see that our output is the elements. So for I in ARR means that you're going to traverse by the elements. Whereas when you traverse by index, it is something like this. For I in range of len of ARR. So where len of ARR stands for the length of array. So here you can see, okay, okay, so here you can see in our output, the next line is basically the index. So if I'm going to use for I in range of something like len of array, it is going to give me the index. So there are two kinds of traversal which you can do in Python. One is by elements and by index. So coming to our linear search. So this is a basic code segment for linear search where I'm passing array and target value as the parameters to the function. And I'm iterating through the elements in the array for I in ARR. So I'm checking like if my target element is going to be that element in the array, then I have to return true or else I'll be returning false. So here I'm considering some random array, which is 27415, and let me give target as 5. So we know that the target is present in the array. So what do you think the output should be? You can post your answers in the chat box. Yeah, great. Okay, so let's see if our output is going to be given like come like element found or not. So let's run this. So here you can see element is found because we have 5 in the array. Now let's check for some value which is not in the array. So let me run this code. So here you can see the element is not found. So this is a basic code implementation of linear search and how it is performed. Okay, so moving on, we have the binary search and ternary search, and these both can also be called as the interval search. Okay, so let's first look into how binary search works. So in case of binary search, we have a prerequisite, which is the data has to be in a sorted order. So you will understand this later as I tell you like how this is working. And you can also tell this is basically working on a divide and conquer technique. And so let's see this example. So here you have some random array, which is like 2, 5, 8, 12, and so on. So basically what you do is like you have some three variables. So let me. Okay, so the three variables are the leftmost value. One is the left index. And then you have the right index. And then finally, you have something called the mid value. So what we are basically going to do here is you're going to like find the mid value, like you're going to split the given array into two parts, and you're going to find where your element is going to lie, like whether it's going to lie in the leftmost array or in your rightmost array. So this basically decreases the number of computations you're going to do. Like in case of linear search, you have to traverse throughout the array and check each and every element. But in case of binary search, that's not the situation. Instead, you're like making it into halves and you're checking in which part your value to be found is lying. So in order to compute the mid, we have a formula which is leftmost element plus leftmost index plus rightmost index divided by 2. And you can either have it as R variable or H, which stands for height. Okay, so basically what happens is, taking this example, we have in the first thing, we have L as 0 and H as 9. So you'll find the mid value, and your mid is going to be 9 plus 0 divided by 2, which is going to give you 4. So in the fourth index, what element you find is 16. So now you will check if your value to be found, that is the target value, if it is equal to your mid value, or if it is going to be less than or greater than your mid, the value present in the mid position. So basically what this does is, in case if your value, say this 23, it is greater than 16, right? So we know that the 23 is going to lie on your right side half of array. So this is why we insist that in case of binary search, our array should be in sorted order. So in case if I have something like 10 or 2, 5, something like that, so that will be less than 16. So I have to take the first half of the array, which is the left array. So now what I'm doing is, since my value is greater than the element present at mid, I will omit the left side part and will move on to the right side array. So now my L, that is the lower index, will be updated to mid plus 1, because here in the third stage, you can find that my L is 5. Because now I only need the right side array and I don't want the left side part. So I'm going to do all my computation within the right side part. So now again, I will find the mid value. So here it's going to be 5 plus 9 divided by 2, which will give me 7. So in the mid position, I have the value 56. Now I'll again check if 23 is greater than 56 or not. So we know that 23 is not greater than 56. So what we have to do is we have to check in the left side position, which is from index 5 to index 6. So basically our left index will remain the same, that is 5, but our high index will be shifted to m minus 1, which is mid minus 1, and that is 6. So now if you check, it is 5 plus 6 by 2, which will give you the mid value as 5. And the element present in the fifth position is 23. So basically you have found the value, like because your target value is 23, and once your mid value is equal, you will return that index. So what we basically do is like, we have three conditions. One is your target is equal to your value at mid. This is case one. And the second case would be your target is less than the value present in mid position. And your third case would be your target is greater than the array, the value present in the mid position. So in first case, what you do is you return the value as such. That is, you return the index, which is mid. So you return mid. But in the second case, what happens is your target is less than the value present in the mid. So what you have to do is you have to update your high value and not the low value. So your low will remain same. But your high or right, whatever you call, will change to mid -1. Similarly, in the third case, where your target is greater than your value present in the mid, what you'll do is you'll update the low value, which is the leftmost value. So leftmost will become mid +1, and your right will remain the same. So this is a basic code snippet of binary search. So let me comment the rest and okay. So basically you're passing an array as well as the target value, and your leftmost index is 0, whereas your rightmost index is the length of array -1. Now you have some condition, like have it as a condition for now. And the basic statements which come inside the conditions are the mid value, which you have to compute, which would be left plus right index divided by 2. And then, so if your mid is equal to your, sorry, if your target is equal to your array of mid, what you do is you return the mid. Now the next case is my target is less than the value present in mid. So here I have to update the right value to mid -1. Similarly, in the else case, it would be updation of the left value, which is mid +1. So now if you see, I have to keep repeating this set of statements again and again until a condition is being met. So the condition would be while your left index is less than your right index. So as long as your left index is less than your right index, you keep repeating these conditions, and finally you get the index that has to be returned. So this is how your binary search will work. So coming to the time complexity, the best case would be 1 here, because say that your element that has to be returned is present in index 4. So here index 4 is your mid value. So basically, if you get the answer in the first comparison itself, then your time complexity would be order of 1. But considering the worst time complexity case, what happens is, first our search space is whole array, but then it becomes half and again half from that and so on. So if this kind of behavior is going to exist, it is called as log n. So your worst case time complexity would be order of log n. So in case of binary search itself, we have further applications like to find if n is a square of an integer, or you are going to find the first value that is greater than or equal to x in a given sorted array, or finding a peak of array which increases and then decreases. So all these kinds of things can also be done using binary search. So in case of the peak of array, the main idea is basically you split them into series of no's followed by yes. So you return the first S value in order to get the output. So say for example, this case, find first value greater than or equal to X in a given sorted array. Say that X is 5 here. So what happens is like, if you are going to, okay, let's say X is 4. So if you're going to like return the first S value, which is 5, so that would be your answer. So similarly, you have lots of binary search applications as well. Okay, so moving on to ternary search. So this is basically the same as binary search, but the only difference is in case of binary search, you are splitting the whole array into 2 parts. But in case of ternary search, what you do is you split the whole array into 3 parts. So you'll basically have 2 mid values, mid 1 and mid 2. And you have a formula to compute the mid 1 and mid 2 value. So here you can see on the screen for computing the mid 1, the formula is your left plus right minus left by 3, whereas for mid 2, it is going to be right minus L by 3. So let's take this example and see how this is working. So you basically have an array which contains some elements which are in this sorted order. So you compute mid 1 first, which is 4 in this case, and your mid 2 is going to be 8. So say that I have to find my target value, which is 19, and I have to return the index that contains 19. So first, I will check if my key value or the target value is equal to the value that is present in mid 1. And then I will also check if this is equal to the value that is present in mid 2. So here in this case, 19 is not equal to 31 and it is not equal to 67 as well. So what I have to do is I have to search in some part, like out of the 3 boxes, I have to search this in one part. So there are 3 conditions, like 3 cases. The first case would be my key value is less than the array of mid 1. So this basically indicates the pink box. So if my value is going to be less than 31, since the array is sorted, I know that my value is going to be lying somewhere in before 31. And in case 2, my key is greater than array of mid. So say that if I have to find some value which is greater than 67, I will be sure that it is lying somewhere after 67 because my array is sorted. And similarly, so that indicates the yellow box. And similarly for the case 3, your value is lying somewhere in between your mid 1 as well as mid 2. So that is the blue box thing. So these are the 3 conditions. And here for us, our value is 19 and 19 is less than the value present in mid 1. So this will come under case 1, which is you have to find it inside the pink box. So moving on, again, what we do is like we modify, like update the value of L and R. So here the L will remain the same because if you see this box, your L for the pink box is going to remain the same, whereas your high value or the R, the rightmost index will change, which will be mid minus 1. That is mid 1 minus 1. Similarly, okay, so can someone tell me like if my, for case 2, say if my value is greater than the value present in mid 2, so what will be my low as well as high value? You can put it in chat, same as how I told for the first case. Okay, good. 9 and 12. Okay, so how do you generalize this, like in terms of mid 2? You can put it in chat. So basically your right index is going to remain the same. So right is same, but your left index is going to change. So how do you write L in terms of mid 2? Okay, very good. So you got the answer. So it is mid 2 plus 1, and then R remains same, which is H. Okay, so like similarly, tell me like what will be the condition for L and H in case 3? That is the blue box. So in case 3, yeah. Okay, great. So you got it. So did everyone understand this? Like, can you give me a thumbs up if you understood? Okay, great. Okay, cool. So let's move on. So this is how this is working. So here now carrying over like how this is going to end. So again, you're computing mid 1 and mid 2 value for the given array that you have derived. Here, what happens is your L is going to be 0 and R is 3, and your mid 1 is going to be 1, and your mid 2 is going to be 2. And you check if your value, the key value, which is 19, is found in mid 1 or mid 2. So here you find that your key value is equal to the value that is present in mid 2. So you basically return that index, and thus it's a success. So coming to the time complexity, so same as how we looked into the other time complexities, the best one would be order of 1, because in case if you get it in the first comparison itself, it's an order of 1 time complexity. Whereas in case of the worst time complexity, here as how we did in binary search, like we were dividing it into half and so on. Here we are doing it in terms of 3. So this is going to be order of log n base 3. So I hope you all understood it. Okay, so now let's see an example code. So insert position. So here you're given a sorted increasing array A of distinct integers and a target value. And you have to return the index of target if it is present in the array. If not, the index where it would be if it was inserted in order. And you're going to consider zero-based indexing. So seeing the example, the sample input. So you have an array 1, 3, 5, 8, and 9, and your target is 5. So what you do is like you check if this 5 is present in the array. If it is present here, since it is present, you will be returning the index of the element 5. So that is 0, 1, and 2. So your index is 2. So you return the output as 2. Similarly, in the next sample, your array is 0, 1, 3, 5, 8, 9, 12, and your target is going to be 7. So here, if you check, 7 is not present in your array. So what should you do? Like you should be returning some index where this element can actually be inserted. So this 7 can be inserted in between 5 and 8, and that index would be 4. So we are going to like try how this is going to work out. So basically, to achieve the first part, which is like to return the value to like the index where this element is found, you can either go with linear search or binary search. But we know that compared to linear search, binary search is more efficient. So like you tell me like in which search is more efficient for this problem, and why do you feel so? You can put it in your in the chat box. Like for this problem, should we go with linear or binary? Okay, binary and two small array, okay. Actually, the binary search is right, but the reason for it is, okay. Okay, so basically, we go for binary search here. So the reason why we go for binary search is like it is more efficient than compared to linear search. And one more thing is like here, they have already given us a sorted increasing array. So it's no use like if you're going for linear search, because like you have to compare each and every element. But since the array given is already sorted in increasing order, it is better to go with binary or ternary search. So here, let's go with binary search and see how this is going to work. So your binary search code will be something similar to this. So if I'm using this code, what will happen is this will return me the index of the element present. So what should I do for the index of the element that is not present? So do you have any idea like what will happen if the element is not present and how we are going to approach with it? Okay, so moving on. So this definition, the binary search thing, this will give me the index of the element if the element is present. But if my element is not present in the given array, this will not return me anything like the target position or any index. So in order to do that, what I have to do is I have to include some more code snippet. So I basically have 3 cases for this. So the first case would be the target that has to be inserted is in the start. And the second case is the target has to be inserted at the end. So the first is you're inserting the target in the start. Second would be your target has to be inserted in the end. And your third case would be your target is inserted somewhere in between. So I'll just put it as in between. Okay, so let's take an example. Say I have an array 2, 4, 7, and 8. So say my target value is 1. So what happens now is I like if you're going with a normal binary search, my mid value, my L value will always remain the same because the value that I have to insert is lesser. So initially, if we compute the mid value, it would be like 0 plus 3 and it would be 1, so 4. So my element is less than the value which is 4. So again, you update your higher index, that is the right index. So you keep on updating only your right index and you will stop when the condition that is left is greater than or equal to right. So you stop there. So basically what happens is your left index is going to remain the same, which would be 0. So your left index in this case would remain 0. So, and you have to insert this 1 in the position which is 0 only. So what you can do is you can return this left index itself. Now coming to the next case. Say your target value is 10. So 10 is always greater in this case, like 10 is greater than 2, 4, 7, 8, and everything. So every element present. So you have to insert 10 at the last position. So when you're performing binary search, what happens is it will always result in a value which is greater than the value present in the mid. So you keep on updating your left value and not the right. So your right index will remain same, which is n minus 1. But here what we have to see is we have to insert this element in the right index plus 1, which is the nth position and not n minus 1 position because we already have 8 in that. So you have to insert it in your nth position. So this is the second case. Now coming to the third one, let's say your value to be the target value is 5. So 5 is also not present in the array. But what happens is in the iteration 1, so in the iteration 1, your mid value would be 1. And the value present in that mid value would be, so it will be 4. Now, if you see your target is greater than 4, right? Like, I mean, it is 5. So 5 is always greater than 4. So what you have to do is you have to update your L value, the left index value. So your left index would be mid plus 1. And this will result in 2. So now you have your left index as 2 and your right index remains the same. Now we'll move on to the second iteration. So here what happens is you again compute your mid value, which is going to give you 2. And the value present in the mid position is 7. So here what happens is 5 is less than 7. So what should you do? Like, can you put it in chat? Like, what should we do now? Should we update the left index or should we update the right index? Right index, that's good. Okay, so I hope that you are understanding it. Okay, fine. So your right index would be mid minus 1. So basically your right index will shift to uh, 1. So now what happens is your condition, which is L less than right, is going to fail because 2 is greater than right. So your loop stops here. And at the end, if you see, your L value is 2. And now if you check this array, like 2478, we have 5. And if you're logically thinking where you have to fit this 5 into, so the index would be like 0, 1 and 2. So in the second index only you have to fit in the 5. So logically thinking, it's in the second index. So what we basically do is, in this case also, we return the L value, the left index value itself. So basically, in the case 1 as well as in case 3, we are going to return the left index. In case 2 alone, what we have to do is, like, we have to check if our the right index is equal to n minus 1. And if that's the condition, you have to return the nth position. So moving on to the code. So I'll just show you like how this is done. So here, if you see, we have all the arguments passed, and n is basically the length of the array, and L is the left index, which is 0, and R is the right index, which is n minus 1. So while the condition like L is less than or equal to R, we keep on repeating all these statements. So our mid value is going to be L plus R divided by 2. And the first one would be like, we are checking if it is equal to target. And if so, we'll return the mid value. And then L if condition and then else condition. So this is basically the normal binary search code. But the extra thing which you're doing is like, you are checking if your right index is equal to your n minus 1. So in that case, you have to return the n. But in other cases, what we did is, like in case 1 and case 3, we returned the left index as such. So here I'm giving a return L. So, okay, let me try. So let's try submitting this. Okay, so we have solved this problem. So this is how this problem is to be solved. And this is like one of the application of binary search. So I hope you all understood. So can you give me a thumbs up if you have understood this code completely? Okay, cool. So we'll move on to the next topic, which is sorting. So sorting basically refers to ordering of your data in an increasing or a decreasing function. And we have various sorting algorithms like bubble sort, selection sort, insertion sort, merge sort, quick sort. There are lots of sorting algorithms, but now we'll concentrate on bubble sort and merge sort. Okay, so the first one is bubble sort. So this is one of the simplest sorting algorithm, and it basically works by repeatedly swapping the adjacent elements if they are in wrong order. So let's see how this example is working. So in the first pass, we have this array 5, 1, 4, 2, and 8. So you check the element at 0th index and first index if they are less, or like you compare them. So 5 is greater than 1. So if I'm going to sort the given array in an increasing or increasing order, my 1 has to be placed before 5, right? So what I'm going to do is I'm going to swap this adjacent element, that is 5 and 1. So in the next iteration, you can see that the 1 and 5 are swapped. Now you have to compare the next two elements, which is 5 and 4. Here, if you see, 4 is less than 5. So again, you have to swap the adjacent elements. So once you swap, you will get 1, 4, 5, 2, 8. Now you consider the elements 5 and 2. So these both adjacent elements, again, you have to swap because 2 is less than 5 and we need 2 to be present before 5. So in the next thing, you can see that we have performed the swap and we have 1, 4, 2, 5, and 8. In this case, if you check the adjacent elements 5 and 8, there need not we need not perform any swap operations. So you can just leave it as such because 8 is greater than 5 and it is placed in the correct position only. So this is your first pass. Moving on to the next pass, what happens is again you repeat the same thing which we had been doing in the first pass. Like if the adjacent elements are placed in the right order, you will not swap it. But if they are placed in a wrong order, you will swap it. So you keep on performing this. And one thing is like how many passes will go on is like it's maximum like n passes. Like if you have n elements in an array, but here we have got the result in the third pass itself. So if we want, we can stop it there itself. So this is how the bubble sort is working. Okay, next I'll give you an overview of the merge sort technique. So in merge sort, what basically happens is you have an array and you split them into two arrays and you keep splitting them again and again into two arrays until you get a single element. And finally, you combine all the single elements in the order, whichever order you want, in ascending or descending, and then you combine, like merge them together, and finally you obtain the output array which is in sorted order. So this is the basic outline of how your merge sort is going to work. Okay, so moving on, let me explain like how this merge sort code is going to work. So this is the one definition part, like which is called as merge sort. And here I'm using a recursive technique. So we are passing the array and the left index and the right index as the arguments. And we'll be checking like if your left index is less than the right index, what we are going to do is like you compute the mid value and you are like splitting them into two arrays. So say like you can see this array 38, 27, 43, 3, 9, 82, and 10. So once I pass this array to the merge sort function, what happens is we compute the mid. So here the mid is 3. So I basically split this given array into two arrays. One is the left array and the right array. So in left array, we have elements starting from index 0 to index 3, which is the mid. Similarly, in the right array, we have the elements starting from index 4 to index 6. So in the next case, what happens is I'm again sending them to the merge sort. This is basically the, okay. So this is basically the splitting step that is happening here, the top splitting ones. So in the next case, again, I'm doing this recursively. So I'll pass the left array separately to the merge sort, and then I will pass the right array separately to the merge sort. So we keep on doing this recursively. And finally, you can find a statement which is like merge of array comma left index, right index, and mid. So this basically means that you are combining them together. This function is for combining them. So I hope you are understanding this example, how this working. So we have split this into two arrays, one is left and right. And after that, you have 38, 27, 43, 3 as one array. And the next array contains 9, 82, 10. Now you again take the left array, which is 38, 27, 43, 3, and you split them into two. Again, a left and right array, which is 38 and 27. And the next one would be 43 and 3. Again, you take 38 and 27, and again, you keep splitting them, which would be 38 and 27. And finally, you merge them. Okay, so this is the function, the code snippet for merge function. So here, basically what we are doing is we are finding the left array and the right array. So left array, the array, the second line, you can find left array is equal to array of left index is to mid plus 1. So this is basically a function called like slicing. This is performing slicing in Python. So let me show you how this slicing works. So say I have an array 1, 2, 5, 3, 7, and 10. Now I need a new array, which is going to be from, I'm slicing it from position 0 to index 4. So 0, 1, 2, 3, and 4. So let me print this for you. Okay, so here you can see my element, the new array contains 1, 2, 5, and 3, which is the first half, like from 0th index to 4th index. So this is how slicing works. So you understood slicing, right? Okay, so moving on, so we have the left array and then the right array, and we'll be like declaring three values, which is the left array index and then the right array index, and then the sorted array index, which I have given as like LAI, RAI, and SAI. So initially they are 0, and the sorted array index alone is equal to left index, because basically once you sort, like you merge, you keep merging it, in the left index part. So you keep on adding it. So that's why your sorted array index will start from left index. So let's see this example, how it is working. So I have an array that is split into two, which is 3, 27, 38, 43. This is the left array, and the right array is 9, 10, and 82. So what we are going to do is, initially my left array index is 0 and my right array index is 0 and SAI is also 0. So I will check if my 0 is, that is left array index, is less than the len of the array, the left array, which is 4. And I also check like if my right array index is less than the length of the right array. So if these conditions satisfy, I'll move on to the next, and I will check if the element that is present in the left array and index and the element that is present in the right array index. I have to compare these both. So 3 is less than or equal to 9. So yeah, this is true. So what happens is I insert the smaller element into my sorted array. So I'm inserting 3 and I'm incrementing my left array index by 1 and I will also increment by my sorted array index by 1. So that's what we are basically performing here. Similarly, in the next case, 1 is the left array index, which is less than the length of left array, and 0 is the right array index, which is less than the length of the right array. So we will compare the elements that is present. So 27 is less than or equal to 9. So this is false. So we take the lesser element, which is 9, and we insert that. So in this case, what happens is you increment the right array index because you have taken an element from right array and not the left array. So you're incrementing right array index. And similarly, you will also increment the sorted array index. So next is you perform the same thing and keep on inserting the values. So this is how the merging is being done. Now, let me tell you another case where your at times your left array can be larger than your right array. So in those cases, sometimes like say this example, 3, 27, 38, 43, and 9, 10, 11. So this is same procedure as the previous one until step 4. So you can see the step 1, 2, 3, and 4. So until step 4, the procedure is going to be same. But once it reaches the step 4, what happens is 1 is less than 4 and 2 is less than 3 and 27 is not less than or equal to 11. So we basically insert 11 here and we increment the index of right array. So you have already inserted all elements of right array, but you have some elements in left array that are left to be inserted, which is 27, 38, and 43. So what you do here is like we have a while statement which will iterate until all the elements of the left array are put into the sorted array, because we know that the left array is already sorted by itself and the right array itself is sorted. So similarly, this can also be the case where your left array is smaller than your right array and your right array elements are left out. So in that case, what you do is you go with the second statement, which is while right array index is less than len of right array. So you keep inserting all the right array elements into your sorted array and keep incrementing and performing the same. So I hope you understood the merge sort. So like, can you give me a thumbs up if you understood, or if you have any doubts, you can post here. Okay, great. So what about others? Okay, cool. So let's move on. Okay, so sure. Isha, like which part do you have a doubt? Like which part did you not understand?
Uh, Isha, maybe to explain it, like explain the idea once again. Uh, so here we keep dividing the array into like Shiba. Can you go to the merge sort like first slide 16?
Yeah, sure.
Yeah, so we keep dividing the array into smaller arrays till each element itself is an array. Now, when we put together the arrays, right, like we have to stitch it back together. So, like the middle line that you see, like each element, like 38, 27, 43, 3, 9, 82, 10, all of them are like, arrays of on its own. Now, when we combine two arrays, we will devise a technique where like we put it in such a way that like both the arrays, so all in, if you imagine like a single element array, they are in sorted order, right? Like there is only one element, they are in sorted order. Now we try to think of a technique where like if we have two sorted arrays, we try to put it together such that like the resultant array is also sorted. So in the case of like very like single elements, we just compare 27 and 38. 27 is less than 38, like so we put it together. Similarly for 43 and 3, 9 and 82, and 10 itself is like a single array. So we got like arrays of size 2, 2, 2, 2 and 1. Now we try to combine the arrays of like size 2 and 2. So that's what like Shiba just explained. We look at like the first element of like both the arrays 28, 38, 27, 38, and like 3, 43, compare 27 and 3. I got 3. 3 is the smallest, so I add 3 to my new array. Now I compare 27 and 43. 27 is smallest, I add 27 to the new array. Similarly, I keep doing like the procedure that Shiba explained. Now once I if I know how to do it like repeatedly, I can put it together to finally get back all the elements in the sorted order. So this is the idea. Code might be confusing a little bit, but then like the simple idea is like you divide the array into single elements. Now all the elements are in sorted order. You combine the sorted arrays back to get a bigger sorted array. So you keep repeatedly applying this idea or logic to finally build back the array. I hope like this clears the idea. So code, you can think about it and add it. Like you can think about how to code it. Like there are different ways of implementing it. So you can try and implement it in like the way you like. Yeah. So
Okay, yeah. So we have lots of sorting techniques. Like at times, like your insertion, selection, or bubble sort may not work because it's order of n square. But you can also go with other sort techniques like quick sort, merge sort, and so on. So here, merge sort is actually order of n log n. This is comparatively efficient than your rest of the sorting algorithms.
So there are like plenty of other sorting algorithms. In yesterday's session, Janmansh was discussing the sort function that was part of the standard template library. So like every language has a inbuilt sort function, and you can assume it to be fast. Try to use the inbuilt sort function, and rather than using bubble sort every single time for your you don't have to write sort most of the time. You just need to understand like how sort works, and you can use the inbuilt sort function, which is like of n log n.
Yeah, so basically in Python, we have a function called array dot sort. So this internally uses something called a stim sort, and this is more efficient also. So you can also go with this sort function. So if we have time, probably like we can see another code, but do we have time?
Maybe Shiba, we can do the merge sort question, or like let's show them the merge sort question. Like movie question can be like maybe they can try it on their own. So
Okay, sure.
yeah, so this sorting array question, like the one that you see here, it's like codel/problem/sorting array. It's just like you have to print it, read an array and like print the sorted array. So you can try implementing your version of merge sort and like bubble sort, or like any sort that you know. There are other sorting algorithms as well. You can read upon it and try implementing, see how it works. So this is like very plain question.
Yeah, and also here you can directly use your sort function also. So I can like show you like this actually works for merge sort. So this was the implementation that I did. So you can basically go with your own implementation as well. And okay, so we have this question, which is merge two sorted array. So this is basically like they have given you two sorted arrays, and you have to like merge these both, which was the last part of the merge sort thing that I was explaining you. So like going into the yeah.
This is the same implementation of the merge sort as we discussed. Probably, I think sorted array and like merge sort you can try on your own with the explanation that we gave. So try implementing it yourself. I think there is a request for us to explain the movie ticket. So we'll skip these two. Anyways, like this is kind of repetitive. You can try the sorted array question and the merge sort question on your own. From the discussion that we had, from the understanding that you had, try implementing it. So let's discuss the movie ticket question.
Okay, fine. So, okay. So here the question is, you're given n people are trying to book a movie ticket, and there are only m tickets available, and each person takes k time to book it, and the ith person starts booking at time pi. So you are always the first in the given n people, and you have to find out if you will be able to get a ticket or not. And the other cases, like if there are multiple people trying to book a ticket on the same time, then if there are enough tickets available, all of them will get. Otherwise, the X people trying at the same time and Y tickets available such that the Y is less than X, then only arbitrarily any Y of them might get the ticket. So you have to print yes if you will definitely get a ticket, and no if you will definitely won't be able to get a ticket, and maybe in the otherwise part. Uh, okay, so this is the input format, and they have also given you the output format. So let's move on to the sample input. So we have basically like 3 test cases, and M is okay. So it is N, M, and K. So there are 4 people, and you have 3 tickets, and each people have taken like 3 as their time interval. So this is the order like 1, 2, 3, and 4. So this is basically your time. Like the first person will book it in the first minute or something of that kind, and the second in the second time, and so on. So here they have mentioned that you are the person who is standing first. So we will book the ticket in the first second or minute itself, and there are rest of the people. So here it is a damn sure like we will be able to get the ticket. But in the like if you check on to the next example where it is 433 and 4321, so here we are actually starting at like booking the ticket at the time 4 only, but there are people who can book the ticket in 1, 2, and 3. So 4 is basically greater value, and there are only 3 tickets available. So 1, 2, and 3 will get the ticket, but we won't be able to get the ticket. So like yeah, and then the maybe cases like 2, 2. So there are 2 or more people trying to get the ticket at the same time. So it is a chance that if we may or may not get. So moving on to the code, this is basically a sorting kind of thing. So okay. So initially, this is the way of getting input in Python. So I'm using map function to map it to the different values n, m, and k, and the split function to split them because I'm getting them together and then splitting them and mapping them as input to n, m, and k. Similarly, okay. So now what I'm going to do is like here I'm using the sort function. So the basic idea is I have an array, say 1, 4, 2, and 3. So initial would be like my time. So let me say my time. It would be 1, right? So because it is in the 0th index. Whereas if you're going to sort it, after sorting, your array would be like 1, 2, 3, and 4. Now there are 3 cases, like 4 cases which you can see. The first case would be you're going, the M is equal to 0. So the number of tickets are 0. If the number of tickets are 0, then no one will get a ticket. So in this case, it's going to be no. Your second case would be my start time is less than the start time of the person who is standing in the mth position. So say that I have only 3 tickets available. So my M would be 3. So in position 3, who is standing is like someone with this value 3. So my value is, my time is 1. So my 1 is basically less than 3. So I will be able to get my ticket for sure because I'm coming before the person with who is standing in the nth position. And my third case would be my start time is greater than the start time of the person who is standing in the nth position. Okay, so now say if my time was actually 4. So in that case, my array would have been like 4, 3, 1, 2, something like this. So in this case, my time would be 4 because I am the one who is standing first in the line. So my starting time is greater than the starting time of the person who is going to stand in the nth position after sorting. So So basically, it is clear that I will not be able to get the ticket because I will come after them, and already there are three persons before me who can get the ticket. And there is a fourth case, which is equal to case. Like my start time is equal to the start time of the mth position person. So say there is something like 1, 2 to 4. So here, let's say that the mth position is uh, like 1, first index. So if I'm going to be 2, there are like two conditions. One is that the total number of tickets is less than the total number of persons. So if the total number of tickets is less than the total number of person and the start time of the mth person is equal to the start time of the next person. So say that M here is going to be 1. So in index 1, you have 2, but the index 2 also contains 2. But you have only okay, 2. So you have only two tickets. So it would be given to 1 as well as the one who is starting at 2. And you will not be able to get, like, it is a maybe case. You may be this 2 or you may be this 2. So it is like an option. So this is the maybe case. Whereas the other cases say this is not 2 and this is 3, but your value is equal to the one at the mth position. So in that case, it is a confirm S, like you will get the ticket. So moving on to the code, it is like first I'm getting the input value of N, M, and K, and then T. And then TM stands for my time, or like my start time. So this is basically the T of 0 before sorting. And after that, I'm sorting the array. And after that, I'm checking the first condition. If the M is equal to 0, that is, there are no tickets to be sold. So in that case, I have to print no. It is obviously a no. The elif condition would be if my time interval is, my start time is less than the start time of person who is standing in the mth position. So this will be M minus 1 because our starting index is 0. So from 0, if we are going to start like 0, 1, 2, 3, it would be in the mth position would be M minus 1th position here. So in that case, if I'm going to be less, so surely I'll get a ticket. So I have to print yes here. The next part is my time is greater than the time of whoever is standing in the mth position. So in that case, I'll obviously not get a ticket because there are already people who are waiting before me, and they will get the ticket before me, and the tickets will get over. So I have to print no. And then the else condition is the fourth case where you have two conditions. One is your ticket has, like, the number of tickets has to be less than the number of persons, and you're checking if they are equal, like your time is equal to the time of one who is standing in the mth position. So in this case, it is a maybe. And here, why we are checking if M is less than N is because there might be a case where like you may have more number of tickets and less number of people. So there may not be a value to iterate. So this might eventually result in some errors. So we are first checking if M is less than N. And in the else part, it is always going to be S because the time period that you are starting is equal to the time of the person in the mth position. So you are that person, so you will probably get the ticket. So I hope you understood this code. Like, did you understand, or is there any doubt in this? Okay.
Uh, yeah, Shiva, can you just check if there is an editorial for this question? Like, I think there should be editorial for this question.
Yeah.
Just click the movie ticket booking from the
Yeah,
problem.
1 minute. Okay.
Yeah, so you have an editorial as well as the setter's code, so you can refer this as well. Shiba already explained, but then if you are still lost or like want to look at more code and then different approach or something like that, like this is you have this explanation plus code, C++ code as well. So yeah. That's it, guys. If you have any questions or like any doubts, we can take like maybe 1 or 2 minutes to answer those. Otherwise, thanks for joining today's session. Hope you join tomorrow's sessions as well. Thank you, Shipa, for a wonderful session. Thanks, everyone.
You're welcome. And thank you all.